In this video, we're going to look at some ways we can deal with time series data. And naturally, I want to deal with time series data in as time efficient a way as I possibly can. In order to work with autoregressive ARMA and ARIMA type processes in R, I need to make sure that I have installed the stats package and have it active or ticked in. I would imagine that this is one of the default packages, so you should have this there already, but if you don't, you know the procedure, I would assume. I'm going to start by just demonstrating how I could run an AR1 process using some stock market return data, which I've already loaded into the R package. As with all regressions that I've run, I'm going to create a regression object. And since this is an AR1 process, I'll just call it AR1. The name of the function I'm going to use is called ARIMA. So AR stands for autoregressive, I stands for integrated order, and the Q is the length of the MA process. So we're going to be doing some ARMA PIQ modeling here, and this is really consistent with all the textbooks, which is brilliant. The next variable or argument I need to pass is the name of the variable I want to run my autoregressive process on. Del is the name of the data frame. I'll use del return as the variable from that data frame. Next, I do comma space. I need to set the order of my ARIMA model. So I go order equals. Now I need to pass a vector. That vector will contain P, I, and Q. So a vector in R, or a list, begins with C and a pair of brackets. So I then have P, I, and Q that I need to type in. If I want to run an AR1 process, P is 1, I is nothing, Q is nothing. I make sure that if I've got two brackets coming on, I've got two brackets going off. Tap return. I've now run my AR1. To get the result out, I'll just do the summary of AR1. And you see, it looks a little bit different here than what we've managed to get in the past. So I may just need to key AR1 as well to make sure I definitely have the coefficients that I need. I'm only expecting to have one coefficient, so I have the AR1, the intercept, and the standard errors beneath them. That's looking absolutely fine. I don't think there's actually much in the summary which particularly helps us, but just in case we do have it. I'm seeing in this because you do get the KQ here. Just a word to the wise, if I don't think we actually have t values immediately springing up. If you divide the beta value by the standard error, that will give you your t stat. Then you can very easily just go and get the t critical values. So that's not really a big problem for us if we're working in R. It's quite common that we will use ARMA PQ type models to actually forecast, and one of the most common types of forecast model stock returns that we might use in the short term is actually an ARMA model, and there's a very specific type. I'll create a new regression equation just to play with this. So I'll call the model ARMA. The function is still ARMA. I'll use the same variable again, just since we're getting the hang of it. I'll use the same variable, same thing again. The order is equal to, then the list. The most common for stock price forecasting is I'll use an AR1 process coupled with a 2-lag moving average process. So I get something like that. And that actually gives me a model which can give me as reasonable as a forecast can be, step ahead prediction for a stock price series. And that's actually used in the real world quite a lot. The ARMA processes are quite good for short-term things. So the ARMA P1Q2 model is actually used in the real world quite a lot, and it's not actually that difficult to estimate as long as you've got the data as you have just seen. One point I should really mention is if we're talking about ARMA models, is the I in ARMA stands for integrated of order. So if I do actually want to run an ARMA model and incorporate first differences into my model, there is actually a shortcut which I can use, and the shortcut is I set the I term in the ARMA to 1. That has the effect of differencing by 1 period, although I guess with time series data you always have to be careful about differencing more than once. Difference of a difference is hard to interpret, but if I were to do that, it would become technically possible. Anyway, I probably shouldn't rant too much on the virtues of forecasting techniques. This video just shows a quite efficient way we can work with time series data when we're not just incorporating it into a rather standard econometric model. And this is a very good foundation for building forecast models, which we can use to make step ahead predictions. Okie dokie, let's leave it there.